This entire Raspberry Pi cluster fits in my hand. Inside this small acrylic enclosure are 4 independent Raspberry Pis, their own dedicated network switch, a system monitoring display, and enough compute power to run a home lab stack. I built the entire thing myself from sheets of acrylic and aluminium using the new Makera Z1 desktop CNC machine. Today I'm going to show you how I designed it, cut and engrave all the parts, and see if we can turn 4 Raspberry Pis into a cool mini data center. Over the past few years, I've built a lot of Raspberry Pi projects, NAS systems, routers, home labs and mini racks. But apart from the large 8-node cluster I built a while back, I've never revisited a Pi cluster. Not because they're difficult to build, but because most of them just end up looking like a pile of boards cabled together. So I wanted to build something that looked like a bit of thought and design had gone into it, something that would look right at home sitting on a desk. So I started designing this. The cluster houses 4 Raspberry Pis, 2 Raspberry Pi 5s and 2 Raspberry Pi 4s, although the trays are swappable so you can run any combination of Pi 3, 4 or 5. Below them is a dedicated 5-port network switch, and on the left is a built-in system monitoring display. This is all enclosed in a custom acrylic chassis with a tinted top and side panels, so you can see the hardware inside it. Node 1 is the primary Pi 5 and drives the portrait-mounted 4.3-inch DSi display. Next to it's a second Pi 5 which becomes Node 2, and so on for 3 and 4. To make all of this, I'm going to be using the newly launched Makera Z1 CNC machine. Makera sent over both the Z1 and their new Cyclone dust collector light system for me to try out. Unlike the last time I tested one of these, this is now the production model, which they've made some improvements to. One of the things I really like about it is that it's capable of working with a huge range of materials. For this build, we're cutting and engraving acrylic, cutting aluminium, engraving labels from bicolor stock, and even adding chamfers to some edges. Normally, that would require several different workshop tools. The enclosure is primarily built from acrylic, and I used Fusion 360's manufacturing workspace to set up the CNC files for the parts. The front, rear and bottom panels are opaque black acrylic, while the top and side panels use a tinted grey, so that the hardware remains partially visible inside. I started out by machining all of the main panel profiles. For these panels, I'm using Makera's 2mm end mill, which leaves really clean finished edges in acrylic. First I made up the front panel. The Z1 has some helpful features like an outline trace to help confirm that the stock is correctly in position and that there's enough of it. It also has auto leveling, which probes the bed and compensates for any gradient or warping. One thing I always enjoy about machining acrylic is watching the parts gradually emerge from what starts out as a completely blank sheet. One of the strengths of a CNC machine over a laser cutter is that you can precisely control the depth of cut in materials. So you can create pockets for inlays and steps for stronger joints. With the main profiles cut, let's move on to the top tinted panel, which features a large Raspberry Pi logo that sits directly above the display. To do that, we'll switch over to an engraving bit using the Z1's quick tool changer. The Z1 also shows you which tool to change to using an LED bar in the tool head. The engraving adds a nice visual detail without making the design look busy, and because it's machined directly onto the acrylic, it feels a lot more premium than just adding a sticker to it. This panel also gets chamfered edges, so again we can switch tools, now over to a chamfer bit. Next up are the aluminium handles. For these I switched over to a 1/8 inch metal cutting end mill. The handles on either side of the enclosure are decorative rather than functional, but they help make it look like a miniature rack-mounted cluster. Once the profiles were complete, I also added chamfers to soften the edges and make them feel a bit more like a finished product. You can also get a 3D probe for the Z1. This makes it really easy to pick up a reference point for two-sided jobs, or to get the center of cylindrical workpieces. It's load-based, so it works on both conductive and non-conductive materials. Lastly, we need to make up the aluminium labels. These are cut from a piece of bicolor stock with aluminium on the front and black backing. To engrave and cut these, I'm going to use a cool accessory available for the Z1, a vacuum bed. This bed cleverly makes use of the cyclone dust extractor to suck the workpiece down onto the bed, allowing you to quickly and easily use thin stock without having to clamp it down each time. For smaller aluminium sheets like these node labels, it works really well. It also means there are no clamps getting in the way of the tool path, so you can run closer to the edges. We'll use an engraving bit to engrave the labels, and then an end mill to cut them out. The Cyclone Dust Collector light works really well to collect chips during cutting and engraving, and also to vacuum up the inside of the Z1 after use. It's also impressively quiet, running at just 70 decibels flat out, which is a lot less than a typical shop vac, which would sound about twice as loud. And that's all of the parts complete. Now I just need to go through the usual cleanup to remove their tabs and sand the edges smooth. With that all done, we can move on to assembling the cluster. Most of the acrylic structure is bonded together using weld-on acrylic cement. This creates a really strong joint and leaves the assembly looking almost seamless. It's also quite easy to use because you can set a joint and the thin cement wicks into the seam afterwards. The top panel is removable and secured using screws, so the cluster can still be serviced later. The handles are also screwed on since acrylic and aluminium don't really like being glued together. Lastly, I stuck some rubber feet to the bottom so that it doesn't slide around, and it has a bit of vibration dampening. The cluster is powered from a single 5V power supply connected through an XT60 plug at the rear. Instead of having 4 separate USB supplies, all 4 powers are powered directly through their GPIO pins. This keeps the wiring cleaner and makes the entire system much more compact. Each Raspberry Pi is then mounted onto its own removable sled using M2.5 screws. The sleds can slide out individually if a board ever needs to be replaced or upgraded. The Ethernet and USB ports all face forwards, and the microSD cards remain accessible through cutouts on the back panel. This means I can swap operating systems or update individual nodes without dismantling the cluster. The switch mounts directly underneath the nodes. 4 ports connect the nodes together, and the 5th is left available so that the cluster can connect to the rest of my network. Alongside node 1 goes the display, which is held in place with 4 screws around the edges. It connects to the Pi alongside it with a DSI ribbon cable. A single 60mm fan on the top panel provides cooling to the 4 Pis beneath it. The top panel can then be closed up with some M2.5 screws in the corners. And that's the hardware complete. For the display, I created a custom cyberpunk-inspired dashboard running in Chromium kiosk mode, and this opens up automatically on startup. The display shows information from Node 1, including system load, storage usage, memory utilization, network information, and other live statistics. It doesn't just make the cluster easier to monitor, it also acts as a mini control panel. It's a full touch display that you can use to do anything you'd usually be able to do on the Pi desktop. You can also set it up to provide summary stats for all 4 nodes or cycle through pages from each node. So here's the final build. We've got the cluster of Raspberry Pis in a compact acrylic enclosure, with networking, custom monitoring, and without a mess of cables. The tinted acrylic panels let you see the internal hardware. The aluminium accents add a bit of contrast to the black panels, and the display brings the whole thing to life. A huge thank you to Makera for sending over the Z1 and Cyclone dust collector light that I used for this project. The Z1 has just been launched and is now available to order. If you'd like to learn more about them or get one for yourself, I'll leave links to them in the description below. They're also soon launching Makerables, a CNC project sharing platform for the community to share designs and files. If you've got any ideas for what I should run on this cluster, let me know down in the comments. Should I go with the usual Kubernetes or Docker Swarm, or rather try something completely ridiculous? This setup would be great for Kubernetes, because you can use the display to run the web dashboard and see resource usage and the pods you've deployed across the cluster. If you enjoyed the build, please give the video a like and subscribe to the channel. As always, thanks for watching, and I'll see you in the next one.